Let's look at what is due this week, so you'll know where you're at, if you're current or not. Put this up on the screen. All right, this week is week 31, so you should be doing this work here, 713, 714, 715. So we're talking about inverse matrices this week and how to determine if it's invertible, if it has an inverse, and then finding the inverse of a 2 by 2 matrix. So that's where you should be. You should have everything done up until this point. So just showing you where you need to be as of now. Okay, so let me go through and do a little examples of what it's talking about with these invertible matrices. Inverse matrices. So let's talk about what an inverse is first off, because we have inverses in all kinds of math. If we have the number 9 and we want the inverse of 9, that would be 1/9. 1/9 is the inverse of 9. It's something when we multiply them together, they're going to equal 1, which is numbers. So there are inverse matrices also. Now let me just show you what the inverse matrix is. Let's say a 2 by 2. The inverse matrices are always square matrices. So they're 2 by 2, 3 by 3, 4 by 4. I'll put those examples up here and you can keep going if you want to. 1, 0, 0, 1. That is the 2 by 2 inverse matrix. 3 by 3. 1, 0, 0, 0, 1, 0, 0, 1, 0, 0, 1. The 4 by 4, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. You can see the pattern. It's just the diagonal ones. Those are inverse matrices. And if we have I'm going to call that I for the inverse matrix. If we have a matrix, let's name it A, and we multiply it by the inverse, you're going to end up with A again. Same thing, and this works both directions. As long as it's a square matrix, if A is a square matrix, then you can do it either way, AI or IA. Let's look at an example of how that would work. 1, 0, 0, 1. That is the inverse matrix. Now let's say we take any square matrix. So we're going to call it A, B, C, D, because we don't care what the numbers are. It can be any square matrix, any square 2 by 2. That's going to equal, all right, got to remember how we do. We start out first row, first column. So 1 times A is A plus 0 times C. 0 times C. That gives our first one. Now our second one, we do the first row by the column. So that would be 1 times B, 0 times D, plus 0 times D. Okay, see what we got so far? A plus 0 times C is just 0. So far we got A. B plus 0 times D would be 0, so it's just B. Down here, right, we take, let's do this one. This row times this column. So it's 0 times A. And 1 times C is just C, so plus C. A times 0 is 0, plus C is just C. And then for the last one, we do this times the last column. 0 times B plus 1 times D is just D. So 0 times B plus D. Look at that, we end up just where we started with A. So when you take an inverse times any matrix, any square matrix, you'll end up with that square matrix again. So if we called this matrix A, and we got A again at the end. And we could have reversed those. We could have had A first and then the inverse matrix, and we would still end up with the same thing. All right, so let's look at how do we find an inverse? How do we find an inverse matrix? Because this is just multiplying the identity. I'm sorry, I keep calling this the inverse. This is the identity matrix. Identity. I know we're in inverse today, so I'm not using that. This is the identity matrix. I'm sorry. Identity matrix 2 by 2, 3 by 3, 4 by 4. Let's talk about an inverse matrix, because the inverse matrix has some pretty neat properties too. So the inverse, first you have to determine, is it invertible? Does it have an inverse? Does the matrix have an inverse? Is it invertible? Is the matrix invertible? Okay. To know that, we have to check the determinant. The determinant. All right, so what is the determinant? Let me just put a matrix out here. 3, -4, 2, -5. All right, so to find the determinant, you take these two numbers and you multiply them and subtract what these two are when they're multiplied together. All right, so we'll take 3 times -5. And from that, we subtract 2 times -4. So we take whatever this is in these two corners, multiply them, and subtract what's in those two corners. All right, so 3 times -5 is -15. 2 times a -4 is a -8. So we're subtracting -8, which means we're adding 8. So -15 plus 8 equals -7. So yes, this is invertible. The only way it would not be invertible is if this is 0. If 0, no inverse exists. If 0, no inverse exists. If it's a positive or negative number, you're fine. Just cannot be a 0. And then let me show you why now, because here's how you find an inverse of a matrix. Let's say we have this matrix here. What do I have? Let's use the same one. 3, -4, since we know it has an inverse. So the inverse, and we'll name the inverse A prime. All right, since this is our inverse our matrix A inverse. So the way you find that is it's 1 over the determinant, which is, well, for AD minus BC, if we just use generic, AD minus A times D minus B times C, which is the determinant again. Sorry, I didn't write that real clear. But 1 over determinant, and then you multiply that times. What we're going to do is we're going to take these two, the 5 and the -3, and we're going to trade places. The -5 and the 3 are going to trade places. All right, and then we're going to go with the other two, the -4 and the 2, and they're going to stay where they're at, but they're going to change signs. The negative is going to become a positive, and the positive is going to become a negative. All right. So we have 1 over the determinant, and then these two trade places, these two change signs. So our determinant in this case was -7. So let me write a -7 right here. We'll just -7. So now we multiply these together. You get -1/7 times -5, 4, -2, and 3. This is how we find the inverse of the original matrix. Now, this is just scalar multiplication. It's just taking a number times a matrix, which means we just take a number times each. So negative 1/7 times negative 5/7. And it's positive because that was a negative times a negative. Negative 1/7 times 4 is negative 4/7. Negative 1/7 times negative 2 is a positive 2/7. And 3 times negative 1/7, negative 3/7. So this is what the inverse is to that one. That was the inverse. Now, what happens when we multiply a matrix times its inverse? Let me get another sheet of paper. And I'm going to copy these down. So I'm going to take 5/7, take the inverse matrix. We'll take A prime 5/7. Sorry, I'm a bit shaky. That's what all this cancer treatment does. All the chemo and stuff leaves me really shaky for a while. Hopefully it won't last much longer. Trying to write clearly. Okay, 5/7. There's our inverse matrix. And we're going to multiply it by our original matrix, which up here was 3, negative 4, 2, negative 5. All right, so what does that equal? Remember, when we multiply matrices, first we multiply the first column by the first row by the first column. So 5/7. Now this is a 2 by 2, and this is a 2 by 2. So we know that we can multiply them because these numbers are the same. As long as those inside numbers, this 2 and that 2, are the same number, we can multiply. And what we end up with is what these outside numbers are. We end up with a 2 by 2. So we know the answer is going to be a 2 by 2, the way the matrix multiplication goes. All right, I got those written down. Let's go ahead and move up here to so 5/7 times 3 is 15/7. 15/7. And then negative 4/7 times 2, 2 times 4 is 8, so it's minus 8/7. Okay, so that's the first position. Now for the second position, we go down to this row and this column. All right, so negative 4 times 2/7 is negative 8/7. Negative 5 times negative 3/7, negative times negative, so it's positive. 3 times 5 is 15/7. Okay, now this one down here, we jump down to the second row in the first column. Oh, I'm sorry. First row, second column. We'll change. This is the orange one for the second. So for the first one, again, we go back to the first row, but we jump over to the second column. So 5/7 times negative 4 is negative 20/7. Negative 5 times negative 4 is positive 20/7. And let's see, what do we got? I think I messed something up there. 2/7 times, that's negative 8/7. Oh, I should have. What did I do over there? Second row. Yeah, this was supposed to be the first row. Okay, matrix multiplication. You gotta pay attention where you're at. Let's do this over here first. Negative, that's a plus 15/7. I did this one in the wrong. This was still the first row, so I should have stayed with the first row. The pink. I did the same one twice. You got to go first row, second column for the first row, second column over here. So 5/7 times negative 4/7, negative 20/7. And negative 4/7 there is plus 20/7. So we have 15/7 minus 8/7, that equals 7/7. And we have 20 minus, we have minus 20 plus 20, and that's 0. Oh, here we have minus 20 plus 20 at 0. And there we have negative 8 sevenths plus 15 at 7 sevenths again. So 7 sevenths is the same as 1. 0, 0, 1. So we end up with the identity. When you multiply a matrix times its inverse, which we've done right there, you end up with the identity matrix. Now we're only going to do this on a 2 by 2. You can do 3 by 3s and 4 by 4s as long as they're square matrices. You can do that, but it gets really hairy. It gets really hairy, and we don't want to. It's too easy to get lost. I got lost just doing this. Right, I was in the wrong column there for a minute. So I even got the wrong column here. Second row, first column should have been. It should have been 6 sevenths and negative 6 sevenths. Second row, first column. But still it's 0. Still it's 0. So first column, first row, first column for the first one. First row, second column for the second one. Just look at where you see where you're at. This is the first row, first column. So I multiply the first row to first column. This is the first row, second column. So I take the first row times the second column. And when I jump down here, I'm on the second row, but I'm in the first column. So I got to write the second row times the first column. And then second row times the second column. Easy to get confused on that. I was messing it up myself. But that is how that works. That is pretty much the lessons this week. I'm going to stop sharing that. So if you have questions on that, I don't blame you. It's all very, very tricky with making sure you stay in the right row and the right column anytime you're doing any kind of matrix multiplication. Remember, if you want to know if there is an inverse, you check that determinant. Let me put this back up real quick just to refresh the determinant. A, B, C, D. So the determinant for A, B, C, D is A, D minus B, C. Whatever A and D is, you multiply them together. All right, and then whatever B times C is, you multiply them together and subtract. And that will give you your determinant. That gives you your determinant. And if that's 0, if that ends up 0, there is no inverse for that matrix. So you need to know that for the quiz this week. It has, we have to check to see if it has an inverse. That's how you do it right there. So, all right, I'm going to let you guys go. You can hang around if you have questions. And otherwise, I will see you next time. Those of you whose grades below 70, I'll see you Wednesday. Oh, wait. I won't be here Wednesday during this class period. I have a conference I got to go to, a meeting in Fayetteville. So we will not have class in here on Wednesday. But you can get with me any other time of the week if you want to send me an email. So, all right. With that, I will let you guys go.
Let's get out of here. Word to your multiples. Math, baby.